Good evening to all of you. I'm Soumya Ranjan Nath, recently joined IIT Bhubaneswar as a JRF under the supervision of Professor S.R. Samantre. So today I will be discussing about the theme 8 lab testing and validation, and I'll be going through about the current lab activities that is going on in our lab. So the objectives and deliverables are first of all, we have to develop the AC, DC, and separately, and then a hybrid DC in a simulation platform. That is a Simulink or a DigSilent. And parallelly, a laboratory scale 50 kilowatt AC/DC hybrid microgrid test bed is to be developed with all the renewable energy sources and storage. So, and then the testing has to be extended with the protection and control schemes developed on the RTDS and the Typhoon HL systems. And finally, we will implement this in the power hardware in loop system for the hardware testing. So first of all, this is the microwave testbed architecture that is being proposed at the IIT national level, where we in the AC side, we have a wind farm coupled with a DFIG and a synchronous generator, and we have some micro turbines of 1 kilowatt each and a AC load. And in the DC side, we have a fuel cell and a PV along with a storage. The storage has yet to come. So all these things will be coupled in a DC bus, and these two buses will be connected to a bidirectional AC/DC converter, and the AC bus will be finally connected to the main grid. So these are the snapshots of the laboratory setup that is being developed. So the DFIG, this has come recently. So all these sources have been tested individually. So in the DFIG, we can see the DFIG is coupled with a chopper fed DC drive, where by varying the duty cycle of the chopper, the speed is controlled, and hence the power flow is controlled with the help of this chopper fed DC drive. Here the control panel is from the manufacturer. Actually, the control is dumped into a FPGA board, the VHDL board. So the parallelly we have purchased the VHDL boards also, where we will dump our control logics and put it into the DFIG. And this is a synchronous generator of 10 kilowatt rating. And these two will be connected to the AC distribution panel. Then here we have the PV and fuel cell emulators. These two will be connected through DC-DC converters as shown here. And this DC DC converter is for the storage, which has yet to come. And these will be connected. So here I'm showing this is the AC distribution panel, where the wind farm DFIG setup will be connected along with the synchronous generator. And this is the DC distribution parallel, where the DC sources like PV and fuel cell and storage will be connected. And these two will be connected with the help of a bidirectional AC/DC converter as shown in the below. And finally, this AC bus will be connected to the main utility grid with the help of a synchronizing circuit. So this is the PHL setup that is being proposed, and after the simulation, protection and control logics have been developed, and the Typhoon HIL setup has been tested. It will be tested in the PHL setup for the hardware testing. So I was after the literature review, after going through some papers, this is started the work with a simple PV grid integration, where the PV is connected to the grid, and with the help of a inverter, and I've used the alpha beta DQ transformations, and this is the PLL circuit where the theta is calculated, and this is the current controller, where the maximum power point of power current is fed to the direct axis current to control, and it is sent through a PI controller, and then the PWM pulses are generated for the gate drive of the three-phase inverter. So this is, I've started this work as an initial phase. And this is the implementation of bidirectional process in the Typhoon Agile platform, where the bidirectional converter is highlighted here, the block diagram, where the similar logic is applied, where the grid voltage is where current are sensed, and using the PLL, the theta is calculated, and the parallelly power active and reactive power calculations are being done, and it are matched with the reference what is being needed in the microgrid, the reference, and that is sent to the PI controllers to generate the PWM pulses. So the tentative future work is to actually this all the equipments are being has been tested individually. So we have to integrate and renewable resources along with the storage, and we have to bring it into